Alright guys, here's my Lab4 information. So we started off, here's the Arduino code that we ran. And then as far as the different plots we got, you can see here. We got each of the different sampling frequencies and then analyzing at 75, 100, 215, and 300. And then here, just real quick, these are the square waves and triangle waves. Here's a setup. So right now we're running, this is at 100 for 75 hertz. Here's the end scope. Here is the physical wiring of this. And like, for example, if we change this to 100, we see the impact that that has on the graph and everything with that, and how it adjusts for the frequency domain as well. When it comes to aliasing frequency, this is where we have to do our different calculations. So we have the folding diagram, basically just doing a bunch of math for that. We remember that the Nyquist frequency is 1/2 the sampling frequency, and so then we can see, basically applying the math. You can see the cases I've circled in with black pen are where aliasing applies. The rest of the cases, if there's not aliasing, it's just gonna show up at pretty much the expected frequency that you get. And we see that the cases are actually fairly close, theoretical to experimental, which is really good. And then based off of that, what was the question that it asked for? For this one, it asked to describe the observations. Yeah, and like we said, pretty much what we said, but that sums it up well right there. Alright guys, here's the square wave, again at a sampling rate 500 hertz. Here it is over here using pulse 1. And you can notice here there's a bunch of more little peaks that we see, which is great as far as the observations too is concerned, as we see all those little peaks, where for the triangular wave there's a lot smaller peaks. Alright, here's my my closest to 500 hertz, my triangular wave we're sampling, and then that's at 10 hertz for the end scope.